Hi, algebra students. Today we're going to be working on lesson 1.5, solving literal equations. I'm going to go ahead and share the screen so that you can see the presentation, and I'll talk through it. So hopefully you can see this, and I'll go ahead and start the presentation. So we start off today with the warm-up. So go ahead and pause the video and try these warm-up problems on a piece of paper, and then we'll go through them. Okay, welcome back. So in this first one, this is just a good review. You have your Unit 1 test coming up. This is one where we have variables on both sides of the equation. So we're going to start by using the distributive property. I'm going to grab my pen. And I have here, I'm going to start -2 times x, and I'm going to do -2 times -7. So if I bring those down, -2 times x is -2x. -2 times -7 is a +14. And on the left side of the equation, I still have x minus 4. All right, so I'm trying to get all x terms on one side of the equal sign and all constants on the other. So I'm going to go ahead and add 2x because I'd like my x's to end up on the left. But remember, it doesn't matter if they're on the left or right. So now I can bring down what I have. X plus 2x is 3x. I bring down my -4 equals -2x plus 2x is 0, so that's gone, and I bring down my 14. Next step is to add 4 to both sides. Now I'm working to get my constants on the right side. -4 plus 4 is 0. I'm going to move over here because I've run out of room. I have 3x. Oh, that's a beautiful 3. Equals 14 plus 4 is 18. Divide both sides by 3. And your final solution should be x equals 6. So we can double check, remember. I'm going to switch colors and do my check. Maybe. Let's go with blue. So my solution is 6. So I want to see if that works. I go back to the beginning. Here I'd have 6 minus 2 on the left, or excuse me, 6 minus 4, which would be 2. On the right, I want to know, is that the same thing as -2 times 6 minus 7? Well, if I do 6 minus 7, I get -1, and -1 times -2 is in fact 2. So 6 is the correct solution. All right, on problem number 2, I have the distributive property, and on this side, I'm going to need to combine some like terms. So I'm going to start by distributing. I get 8h minus 8 times -1, -8, equals, on this side I combine 6h plus 2h, those are like terms. I get 8h plus 4. All right, and I'm going to try to get my h terms on the left. So I'm going to subtract 8h from both sides. And it looks like these 8h's are going to cancel. Now, some of you missed this on the quiz, so be sure you don't miss it on the test. If 8h cancels here and 8h cancels here, look to see what you're left. Some people were writing down that they had a variable left at this point, but you don't. You now have -8 equals 4. Since that is not true, this is one where we have no solution. All right, let's go ahead to our next slide. You have some vocabulary. This can be found in your journal on page 24. So go ahead and turn to page 24 in your journal, pause the video, and write these definitions down in your journal. All right. So hopefully you got those written down. We're going to be solving literal equations today, and that means getting one variable in terms of all the other variables and constants in the problem. This is really helpful when we get on to later chapters where we are graphing linear equations to be able to get a y variable by itself. So if I look at number 1, and these are extra practice problems on page 25 in your journal. So extra practice number 1, I have y minus 2x equals 15. I want to get y all by itself. So I look, here's y. I want this y all by itself. So it's 2x that needs to be moved to the other side. Now, I could put it under the 15, but some people get confused and think, oh, that means I can add 2x to 15, but you can't because they're not like terms. So in this case, I'm going to put it next to it, so I'm not tempted to try to add those two terms together. So if I write down what I have left, it's y equals 15 plus 2x. I have the y term all by itself, so I've solved the equation for y, and I just leave my answer like that. All right, let's look at number 2. Again, we're trying to solve for y. Here's my y. That's what I'd like all by itself. So I need to move 4x to the other side. So I'm going to subtract 4x. And again, don't be tempted to subtract it from 2. I'm going to actually write it to the side so that I know I can't combine those. They're not like terms. This has an x, this does not. It's a constant. I bring down my y equals 2 minus 4x. And that's it. All right. This time we're solving for y again, but we have a lot of stuff going on. So my y is on this side. Since y is on the right, I'm going to leave it here. And I'm going to work to get all the other terms to the other side. So I look, are there any parentheses? No. Are there any like terms over here I can combine? No. But I can subtract 8 from the right. And this time I'm going to write it below the 2. Those are like terms. I can combine -2 and -8. So I'm going to do that. These 8's cancel. I'm going to bring down what I have. I have 5x. -2 minus 8 is -10 equals 5y. All right, so there's my y. It's not quite by itself. Right now it's being multiplied by 5. So I want to, I don't know why I can't do that. Let's get rid this time. So to get y by itself, I would need to divide by 5. Now when you divide by 5 on the other side, you're dividing everything by 5. Some people like to make a big long fraction bar, but sometimes you miss things when you do that. So I'm going to ask you to divide everything that's on the other side by the value. So I'm going to simplify that. 5x divided by 5 leaves me with 1x. -10 divided by 5 is -2. And on the right side, these 5's, 5 divided by 5 is 1, so I'm left with 1y. So it's x minus 2 equals y, or I can put the y on the left. I just have to remember to keep the order the same for the other terms. Y equals x minus 2. All right, let's look at number 4. This time I'm trying to get y by itself. I need to move x to the other side. And I end up with y equals 11 minus x. There's no number in front of the y. That's as far as I can go. And that concludes number 4. All right, let's look at the next slide. All right, again, we're getting y by itself. So let's go up to number 5. Okay, this is the y I'm trying to get by itself. It's on the left. So again, if the variable starts on the left, leave it on the variable you want to get alone is on the left, leave it on the left. If it's on the right, leave it on the right. So I'm going to leave that y on the left, and I'm going to move 3x to the other side. All right, I bring down what I have. You have to be careful on this one because it's not just y, it is negative y. So I have negative y equals negative 4 minus 3x. All right, I don't want negative y. I want to know what y is. So I'm going to switch colors here. And in order to get that y by itself, maybe, come on. In order to get that y by itself, I have to realize this number in front of the y is a negative 1. So to get y by itself, oh, that's beautiful. I'm going to divide both sides by negative 1. Remember, you're dividing everything by negative 1. So I need to divide negative 4 by negative 1 and negative 3x by negative 1. When I do that, I am left with y alone. That's what I wanted. Negative 4 divided by negative 1 is a positive 4. Negative 3x divided by negative 1 is a positive 3x. And negative divided by negative is a positive. Notice that it's okay to divide unlike terms, right? I can divide an x term by a constant. I can't add or subtract them. All right, let's look at number 6. Here's my y way over here. Again, if you start with your y on the right, and that's the variable you're trying to isolate, leave it on the right and work everything else to the other side. So I look here, no like terms, but I can subtract 7 from both sides. Bring down what I have. I have 3x. 1 minus 7 is negative 6 equals, 7's gone from the right, negative 4y. Okay, I'm going to switch colors because I got to do a little dividing here. All right, this time to get y by itself, right now it's being multiplied by negative 4. So I need to divide by negative 4. And again, I want to divide every term by negative 4. Okay, if it doesn't go in evenly, it's okay to just leave it as a fraction. So 3 over negative 4 is the same as negative 3/4. Notice it doesn't matter if the negative is in the bottom or the top or the middle. Okay, this is all negative 3/4 x. Here we have a negative divided by a negative is going to be a positive. 6/4 can be simplified, and I'm going to simplify it into 3/2 equals y. Okay. Some of you are thinking, well, I could write those as decimals. The only problem is if you run into something like 2/3 where it doesn't come out as a nice non-repeating decimal, it's better to leave it in its fraction form. And as we get into graphing, the fraction form is going to be much more useful to your graphing. All right, let's look at our next slide. Looks like that's it. So today's assignment is literal equations practice activity. It can be found on today's agenda in Schoology. So please click the link there and complete the activity. It's all about getting a variable by itself. Coming up, your Unit 1 test is Tuesday, October 6th. One thing you need to remember is that all your work from Unit 1 must be turned in on the day of the test, if not sooner. That's it. If you have any questions, be sure to shoot me an email. In the meantime, good luck on the assignment and happy studying.